Now we have some missing number problems for subtracting multiples of 100, 1,000, 10,000 or 100,000. So first, 30,450 minus what equals 29,650. Well, what we can do here is highlight the digits that have changed. We have 304 circled here and then 296 circled in our answer. Now 304 minus 8 is 296, so our missing number is 800. That's 8 with 2 zeros on the end, because we can see that the last two digits of our number, so our tens and ones, have stayed the same. Now 310,300 minus what equals 210,300. Well, here we can see that only the 100,000s digit has changed. 3 minus 1 is 2, so our missing number is 100,000. That's 1 followed by 5 zeros, because we can see that the last 5 digits of our number are the same in our question and our answer. 246,700 minus what is 196,700. We can see that both our 100,000s and 10,000s digits have changed. Now 24 minus 5 is 19, so our missing number is 50,000. That's because the last 4 digits of our number are the same in our question and our answer, so we need 4 zeros, zeros in our thousands, hundreds, tens and ones, to show that it's 5 10,000s that have been subtracted. 677,050 minus what is 669,050. Well, here we can see that both our 10,000s and thousands digits have changed. 77 has changed to 69 in the digits that we've circled. Now 77 minus 8 is 69, but we can see that our hundreds, tens and ones have stayed the same in our answer. So that means 8,000 has been subtracted. 77 minus 8 is 69, and our other digits have stayed the same, so because our hundreds, tens and ones are the same, we need 3 zeros after the 8 to show that it's 8,000s that we've subtracted. So now let's look back to our first question. We can show place value counters to represent the subtraction. We started with 30,450, which we can see represented here. Now we needed to just subtract 800. So we can subtract 1, 2, 3, 4 of our hundreds. But now to get more hundreds, we need to exchange. We can take one of our 10,000 counters and exchange it for 10,000s, and then we can take one of our thousands and exchange that for 10 hundreds. So now, because we've already taken away 400 counters, we can take away 5, 6, 7, 8, and we can see that that leaves us with 29,650. So here, the 10,000s, thousands and hundreds digits all changed, and that's because we needed to exchange to subtract 800s. Then we had 310,300, and we saw that in our answer only the 100,000s digit had changed, so we'd just taken away 100,000 to give us our answer. Then we had 246,700, which we can see represented here with place value counters. We saw that subtracting 50,000, so subtracting 5 10,000s, would give us our answer. We can subtract 1, 2, 3, 4, then exchange one of our 100,000 counters for 10 10,000s, and then subtract our fifth 10,000. So we can see that now we have 100,000 because we needed to use one of these counters to exchange, and we have 9 10,000s. Now 677,050 is shown here using place value counters, and we saw that subtracting 8,000 would give us our answer. So we can subtract 1, 2, 3, 4, 5, 6, 7. But then, to subtract an 8th thousand counter, we need to exchange one of our 10,000s for 10,000 counters. So now we can subtract our 8th thousand, and that means that we now have only 6 10,000s because we needed to use one of them to exchange, and now we have 9,000 counters.